Hello and welcome to another one of D's ADD videos. Today we're going to be looking at this example of trigonometric substitution. Now you know it's trigonometric substitution because I'm telling you so, but had you not known, what you should do is you should approach this integral just like you approach any other integral. And you should have a game plan or series of integral techniques that you try to solve each one of these problems. And there's a certain order you should try them in. A hierarchy. And the first one is you should try to do them separately. If they were just added, subtracted in the numerator, you could do the integral of x squared then plus 9. But you can't in this case because they're in the denominator. So the denominator prevents us from doing these separately. They need to be in the numerator without this thing that groups them together. Next, what you should do is you should try to do some algebra or trig to rewrite the problem. In this case, you can't really do any algebra. There's no separation of numerators. You can't separate the denominator, only the numerators. You can't do long division because the power of the bottom is greater than the top. There's no algebraic manipulation you can do here. And there's no trig, so we can't use any trig identities. Next, we should try to do u substitution. And in u sub, we need one part to be u and derive it to get the other part of the problem. So if I let u equal the more complex expression, the du is 2x, I would need an x on top to do u substitution. And clearly we don't have an x there, so no u sub possible. So then we try to do integration by parts. In this case, the only thing you could really do is let dv equal dx, and then your u would be x squared plus 9. It might work, it might not on some of these, but it should honestly just stick out to you as the formula of u equals a tan theta. All right. Actually, to be honest with you, if you've done enough of these problems, you've memorized some of the basic inverse trig ones, this immediately should tell you 1 over a arctangent u over a. But in this case, if you don't recognize it, then you have to do trig substitution. And that's what we're going to do here. And it's a pretty straightforward problem, so that's why I chose it. I know that you can do the formula for this and get 1/3 arctangent x over 3 plus c immediately without doing any steps. That would be acceptable. Okay, but let's say that you didn't recognize that. What would you need to do? After going through and recognizing that it's trig sub, having forgotten the formula, you would recognize that it's this pattern because we have a u squared plus an a squared. Okay, now that we recognize it's u equals a tan theta, we got to figure out what u and a are. U squared equals x squared and a squared equals 9. So if I square root both sides, I figure out what my u and a are. Now that I know that, I can plug into my substitution of u equals a tan theta. Now I can start finding my dx, which is just the derivative of this side. And I don't solve for d theta like I used to, so I just keep it over here because I'm going to be plugging in what dx equals up here in terms of trig. Also what x equals in terms of trig. X equals 3 tan theta. So when we plug in terms of trig, this is our new problem. And hopefully we can simplify this new problem into a much easier integral. So this was my dx term. This was my x term, and I got my x from here, and my dx from there. Now it's a matter of simplifying, so we got to square this, bring out the 3, use our trig identity of tan squared plus 1, and when we do so, factor out the 3, square this, you get 9 squared, or 9, you get 9 tangent squared, theta plus 9, factor out that 9, bring it out in front, then tan squared plus 1 equals secant squared, they can cancel, and all that simplified to the integral of d theta, which is much easier, would you not agree? And all these substitutions, when you do your substitution correctly, you should go from a more difficult problem to something that you can integrate pretty easily. Otherwise, you've done it wrong. Or probably you can't, you're not supposed to be doing a substitution. So the integral of 1 is always the variable to the first power, and the variable is theta. So it would be theta to the first with the 1/3 coming down. And now, because I didn't start out with thetas, I started out with x's, I have to go back in terms of x. And the way I do that is with my original relationship that I had, x equals 3 tan theta. Now in this case, I can actually just solve for tangent by dividing both sides by 3 first, then arctaning both sides. And if I plug that into here, I get this answer here. Which, if you remember at the beginning, I told you from the formula, it's 1 over a arctangent u over a. All right? So that's basically it. When we're doing these, sometimes we'll get sines, cosines, and other things in our answer. In that scenario, you will need to create a right triangle based off of this statement. Tangent is opposite over adjacent, if you remember from trigonometry. So you can set up a right triangle, use Pythagorean to find the missing leg, and then figure out whatever trig term you need to figure out in terms of your original variable. Okay? You can check that out on intermediate and advanced videos where I'll be doing those type of problems with the triangles. But this was more of an introduction, so I hope I've eliminated any doubts that you might have in trigonometric substitution. The main thing is for you to practice as many problems as you can to eliminate your insecurities and nervousness. Thanks for watching. I hope you have a nice day.